For decades, the aviation industry has been stuck in a cycle of repetition, relying on outdated designs, stubborn traditions, and the same fuel-burning machines that have dominated for more than half a century. The names at the top have barely changed, but their approach to progress has. Instead of innovating at a pace the world needs, aerospace giants like Boeing have stumbled through one failure after another, burning through billions while losing public trust. Boeing, once considered untouchable, has faced setback after setback, scandals, and safety issues that dragged its name into headlines for all the wrong reasons. Since 2019, the company has recorded a staggering $32 billion in losses, a number that not only shows financial collapse, but symbolizes how deeply broken the old system of aviation has become. Planes are still heavy, inefficient, and painfully dependent on jet fuel. While the rest of the world has been demanding cleaner, faster, and more affordable transportation, that vacuum of innovation has left the skies open for disruption. And as history has shown time and time again, whenever there's a space for radical change, Elon Musk is never far behind. Enter Tesla's revolutionary supersonic electric plane with vertical takeoff capability. A machine that doesn't just aim to compete with existing jets, but to completely rewrite what's possible in aviation. While others have clung to tradition, Musk's bold vision attacks the core weaknesses of modern aircraft: the reliance on fossil fuels, the weight problem of fuel burn, and the limitations of aerodynamic efficiency. Instead of following the template of a conventional airliner, Tesla's aircraft is engineered from the ground up with entirely new principles. Imagine a plane that takes off vertically like a helicopter, eliminating the need for long runways, and then accelerates forward into supersonic speeds with distributed electric propulsion spread across compact wings. The design isn't just futuristic. It's a step into an entirely new era of aviation. Where sustainability and performance merge seamlessly, this new aircraft is said to be capable of flying 1,500 miles on a single charge, a range that covers the majority of commercial flights worldwide. The implications are massive. A journey that once required burning through thousands of gallons of fuel could now be completed with electricity, slashing operational costs and making flying dramatically cheaper for both airlines and passengers. Instead of dealing with fluctuating oil prices, operators could rely on a stable and increasingly renewable grid, or even on-site solar and battery systems directly connected to Tesla's vast energy network. In Musk's world, flying no longer needs to be an environmental liability or a financial gamble. It can be efficient, affordable, and clean. But the real genius of the design isn't just in the power source. It's in how Tesla is redefining aerodynamics itself. Traditional aircraft are always playing a balancing act between lift, drag, and weight, with compromises built into every design. Tesla, however, is introducing a lift-to-drag ratio that has never been achieved before. Compact wings, combined with distributed propulsion, allow for unprecedented efficiency in flight. Every motor works in harmony, controlled by advanced AI that constantly calculates the most efficient way to keep the plane airborne while minimizing drag. This isn't just a redesign. It's an entirely new category of aircraft. Instead of the loud, fuel-hungry jets that dominate airports today, Tesla envisions sleek, silent, electrically powered planes gliding across the skies at supersonic speeds. Step inside this aircraft, and the changes are just as dramatic. The cabin isn't about squeezing passengers into rows of cramped seats while maximizing profit per square foot. Instead, it embraces Tesla's philosophy of comfort through simplicity and advanced design. With vertical takeoff, boarding, and airport infrastructure can be transformed. Smaller local hubs could replace massive runways, meaning flights are more direct, more frequent, and less stressful. Inside, AI systems manage everything from flight paths to passenger safety, ensuring an experience that feels smooth, futuristic, and almost effortless. While traditional airlines still rely on human pilots juggling hundreds of variables at once, Tesla integrates AI Starlink connectivity and quantum-inspired error correction to guarantee safety levels beyond any human pilots. Capability. Quantum-inspired error correction might sound like science fiction, but in practice, It means the aircraft's systems are capable of detecting and correcting faults in real time, ensuring reliability at a level conventional planes can only dream of. Pair that with Starlink satellite internet beaming down constant, uninterrupted connectivity, and passengers could enjoy high-speed internet at 40,000 feet without the spotty, expensive in-flight Wi-Fi we've all gotten used to. More importantly, Starlink integration allows the plane to communicate constantly with global networks, feeding real-time data into Tesla's AI decision-making systems. Every movement of the plane is guided by calculations happening faster than a human brain can even register. When we talk about safety in the skies, it's not just about building a strong aircraft anymore. It's about building intelligence directly into the machine. Tesla's motor technology also pushes boundaries that make this leap possible. With 95% motor efficiency, energy is converted into thrust with almost no waste. Compare this to traditional jet engines, which bleed efficiency at every step, losing massive amounts of energy as heat, vibration, and noise. Even more astonishing is the way Tesla has addressed one of the biggest challenges in aviation: weight. In a typical fuel-powered jet, weight decreases as fuel is burned, which constantly changes the dynamics of flight. Pilots are always recalculating balance and lift as their aircraft becomes lighter over time. With Tesla's electric system, battery packs are designed to maintain constant weight, meaning stability is never compromised, and the aircraft can be optimized for performance across the entire journey. When you combine supersonic speeds, vertical takeoff, constant weight balance, and a motor efficiency near perfection, you get a machine that could replace outdated fuel-hungry jets practically overnight. The operational advantages are undeniable. Maintenance is lower because electric motors have fewer moving parts compared to roaring jet turbines. Noise pollution is reduced dramatically, opening up the possibility of flights taking off and landing in urban areas without disturbing millions of residents. And with vertical takeoff, cities that were never designed for sprawling airports could suddenly become hubs of aerial transportation. This isn't just about upgrading planes. It's about rewriting how global mobility works from the ground. Every mile flown by Tesla's aircraft is a direct challenge to the old aerospace giants. Companies like Boeing and Airbus, who once seemed untouchable, are now staring down a competitor that doesn't play by their rules. While they grapple with regulatory scrutiny, outdated supply chains, and financial crises, Tesla is moving forward with a clean slate, combining expertise in battery technology, AI, and manufacturing efficiency honed at its gigafactories. It's not just a plane, it's the culmination of everything Tesla has learned from building electric cars, energy networks, and even space rockets through SpaceX. Musk has often said that the key to making life multiplanetary starts with solving energy and transportation on Earth. And this aircraft is a clear extension of that philosophy. The biggest question isn't whether Tesla can build this plane. All signs point to the technology being within reach by 2026. And Musk has never been one to shy away from impossible challenges. The real question is how fast the world will accept it. Will regulators adapt to this new form of flight, or will they cling to outdated rules that favor legacy companies? Will the public embrace the idea of electric supersonic travel, or will skepticism slow adoption? One thing is certain. History shows that once people experience a leap forward in convenience, cost, and performance, there's no going back. Just as Tesla's electric cars once seemed like a niche product, but now dominate global EV markets, its aircraft has the potential to flip aviation on its head almost overnight. For passengers, the benefits go far beyond lower ticket prices. The environmental impact is revolutionary. Imagine slashing global airline emissions not by 10 or 20%, but by eliminating them altogether on most short and medium-haul flights. Cities would be quieter, skies would be cleaner, air travel could finally align with the climate goals the world has been struggling to reach. For airlines, the economics are undeniable. Lower fuel costs, reduced maintenance, simplified infrastructure translate into higher profits and more affordable service. For governments, this is an opportunity to lead in clean technology, investing in infrastructure that not only meets the needs of citizens, but also sets the stage for global leadership in the 21st century. Tesla's timing couldn't be more perfect. The aviation industry is desperate for reinvention. Passengers are demanding cheaper and cleaner flights, and governments are under pressure to reduce emissions. While Boeing counts its billions in losses and struggles with reputation, Tesla is offering a vision of the future that feels inevitable. Supersonic electric flight may sound like a fantasy, but so did reusable rockets, affordable mass-market EVs, and global satellite internet until Musk made them real. This plane represents more than just an engineering achievement. It represents the beginning of a new era in human mobility, one wherein